Alright. Just want to go over these questions real quick. Oh. Let's try something else. Try something different. Alright, so with this question, alright, look, it's which two terms can be combined, okay? And looking at the answer, alright, and what you selected looks like you understand what you're doing because you're picking the ones that are the same. Okay, so like that's good. That's like happy. Oh my goodness, my happy faces. My happy face. There you go. So it looks, because M and this M can be combined, but that's not the question. They want to know, like, oh, I'm sorry. I went the other way. This is the answer you picked, and that's not correct. But look at the answer that is correct. And then let's look up here, right? You look at this 6. Are there any other numbers that are just by themselves? Like, are there any other like 5s or is there a 10? You know, there's no number by itself, right? And then if we look at N, this little N, try to get in there, real skinny link. We look at this one right here, okay? There's no other N in there. There's a 6, there's no N. There's 3.2, no N. There's an M here, but there's no N. So this guy's by himself. So we can kind of get rid of him. We can get rid of the 6 because the 6 is by itself. And the only two things left are these guys, right? So those are the only ones we can combine. Alright, let's move to the next one. Alright. So the temperature in Nico's town is negative 2.8. So I don't know what I'm going to do with that. Maybe I'm just going to start with that. Word problems are kind of tricky because they can just be confusing, basically. There's no way to get around that. They're just, word problems can be tricky. I mean, I miss word problems. Today I miss word problems. But a good hint or tip for a word problem is, as they give you something, just write it down. So I'm just gonna write negative 2.8 degrees Fahrenheit down. Alright, the temperature increased. So what does the word increase mean, right? Right? Increase means it's added. Something is added. Okay, and then it says a rate of 1.3 degrees per hour. So I can write 1.3 degrees here, or I'm just going to put it off to the side for a second. You'll see why. The keywords are rate and per hour until 6 is why I'm going to put it over here. Alright, so then the temperature decreased. So then after we get this answer, what is it going to do? It's going to decrease by a total of 3.7. So whatever we get, it's going to decrease by 3.7 degrees. What was the temperature at midnight? So negative 2.8, good. Now, they said it increased at a rate of 1.3 degrees per hour till 6. So, how many hours was that? Well, it's noon. So, noon, and then 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m. That's 6 hours. So, for 6 hours, it's going up by this much. So, let's just multiply by 6. Alright, then that's 18, and then 6 times 1, 7. 7.8. Alright, now here's the trick here. This is a tricky problem. Because these two signs are different, we're going to subtract these numbers. Okay, so Maybe I go off on the side and I go 7.8 minus 2.8. Alright. So I'm gonna go 8 minus 8 is 0, 7 minus 2 is 5, 5.0. Alright, try to make this where we can see it. Degrees Fahrenheit. Alright. Now, because the signs were different, I subtracted, and then I'm going to keep the sign of this number because it's bigger. 7.8 is bigger than 2.8. It's positive, so this is positive. And just like the problem said, now we're going to subtract by 3.7 degrees because that's what it decreased to by midnight. They're not going to make us do any funky math. So we're just going to have to do that. Okay. So we can't subtract here, so let's borrow. 10 minus 7 is 3. This is now 4 minus 3 is 1.3 degrees Fahrenheit. And you'll see that's what the checkbox has. What is the value of the expression below? Okay, so here all we got to do is actually just do the math. And again, these are kind of confusing because it's a lot to look at. It's a lot to take in. I'm reading 14 divided by 2 plus 3, 4, or times 4 minus another one, 6.5 minus 3. Alright, for these problems, because you have to do this in every problem if you don't know it or not. Alright, you gotta use PEMDAS. And because there's no variables, we're actually gonna do PEMDAS in the correct order. So any parentheses right here. So what is 6.5 minus 3? And there's two ways to do this problem. Like a really easy way, a really complicated way. But sometimes in math, we just have to see what we're doing and just do it instead of trying to get too mathematical. And what I mean by that is, what if we have 6.5 and we subtract 3? I'm not going to put my 3 over the fraction. I'm going to put my 3 over the other whole number, right? And kind of treat this like a decimal. A half minus nothing. Just put a half down there. You can't use this in every problem, but this is a good thing to start looking for so you can use these tricks, because you're not cheating. These aren't like tricks that as long as you learn the rules, it's awesome. They'll work. And then what is 6 minus 3? It's 3.5. So up here, we just want to go 3.5, and then we're really just going to rewrite this whole thing. I mean, we could do some of this, but let's just keep it nice and simple real quick. Minus, here, let me move that 3.5 over. Use my eraser. Alright, so back to PEMDAS, right? So parentheses, we have one right there, but there's nothing to do in it. Exponents, no exponents. Multiplication and division, we do. And the rule is when you have more than one, you just do them left to right. So first, we have 14 divided by 2, and that's 7. So that gets rid of this. Now what's 3 times 4? 12. And then minus 3.5. Oops. See, there I go even, putting a little decimal sign. And now we did a row, so we go back here. PEMDAS, so we know we have nothing left except addition and subtraction. And the rule is left to right. So 7 plus 12 is 19, minus 3.5. Now again, we're lucked out because we can still use this trick. 19 minus 3.5. What if I were to borrow here, and this would become 1? This becomes a half. This becomes 8. This becomes 8 minus 3 is 5. 1 minus 0 is 1. 15.5. Just put that right there. And look right there. Pretty cool, huh? Alright, wait, do we need this? Using the order of operations, what should be done first? when evaluating the expression. Okay. By you putting divide, I think you understand order of operations pretty good. But after we talked about this PEMDAS, what should you have done, right? Plus you see the answer. But we look for parentheses first. Come over here and look. And it's right here, right? And what's inside the parentheses? 9 plus 3. And that's what they've written. Lastly, coefficients. You gotta know this for life. And once you get it, you'll be like, oh my god, this is so easy. Right? So let's say in anything. Alright, this little expression I just wrote. A coefficient. I don't know what they said a coefficient is. But in coefficient, I learned to just look at this word, co. What does co mean? ¿Quieres bailar conmigo? Right? With. Co and cone, like with. That's how I look at it. And with what? Coefficients go in front of variables, right? So coefficients go in front of variables. So in this problem, my coefficients are 7 and 2, right? Because they're right here. I should have made this a different number, like 8. If I have like 3x plus 2z minus 10, 100 plus, my coefficients are just in front of the variables, right? One more thing before we wrap this one up. Oops. Let's say we have. Let's say we have 2/3 x. 2/3 is still a coefficient. If we have x over 2, and this one might be a little tricky, but the coefficient here is just 1 over 2. And that's hard to see, but when they look like this, like right over here, you just kind of have to, or yeah, like right here. Oh, you even got the negative third right. So that's actually good. Just imagine a little invisible one. Little invisible one right here, but it looks like you understand that. Alright, that's it. I think you have retakes. So good luck.